Hi guys, welcome to Technical Rope Rescue Level 1, or should I say Awareness Level. We don't have levels anymore, we have Awareness, Operations and Tech, even in the NFPA 1006. So we're going to go through the requirements for the initial arrival of a first-in truck at a technical rope rescue incident where it hasn't necessarily been identified from the outset that what you're responding to is a technical rope rescue in nature. At the end of this presentation, you will be able to recognize what constitutes a technical rope rescue, identify the 3 levels of response and the duties contained therein. You will know the duties and limitations of the responders at the awareness level, know the appropriate PPE required, understand the hazards and hazard mitigation at a technical rope rescue incident, and know the requirements of setting up zones and performing site control. So what is technical rescue? Well, technical rescue is one of 18 disciplines defined by the NFPA 1670, in which I think Chase Sargent probably best described it. Chase Sargent was a member of the NFPA 1670-1006 committee, and he defined technical rescue as being as special ops for the fire service. Specialized equipment, specialized personnel with specialized training. For technical rope rescue, that specialized equipment comes in the form of specialized PPE, harnesses for example, different helmets to what we normally wear on the truck, different gloves. It comes in the form of connectors or carabiners, descent control devices, life safety ropes, pulleys. That specialized training comes in utilizing the scientific principles of physics and gravity, utilizing gravity to our benefit, utilizing force vectors to our benefit, utilizing friction and pulleys and mechanical advantage systems to safely transport a patient in and out of that vertical or semi-vertical environment. And as for specialized personnel, well, not everybody likes the height. Not everybody can handle the natural built-in fears that we have towards vertical environments, the fear of falling. Same way with claustrophobia. Everybody has a degree to which they become claustrophobic. Everybody has a degree to which they feel the anxiety placed upon us, instilled on us by the fear of heights. Many fire departments still don't recognize, however, when they've crossed the line from a regular response or a normal response into the realm of a technical rescue response. And it's very important that we identify that in the emergency response as quickly as possible so that we can get that next level of response coming. We need to recognize that technical rope rescue incident for what it is and ensure that we don't get over our heads and that we don't put our firefighters in harm's way by asking them to do things that they're not trained or equipped for. It's not that technical rescue in and of itself is any more dangerous than a structure fire. In actual fact, it's quite the opposite. There's very little more dangerous than being first in on a structure fire. However, technical rescue falls into that hazard curve paradox that we are familiar with of high risk with low frequency of calls. The problem with low frequency of calls is that we don't have that experience base in which to build our knowledge to support our training. Therefore, we have to make up for that lack of experience with additional training. We have to remove that deficit, so to speak, and increase our safety by increasing the amount of training that we have for technical rescue incidences. Okay, let's start by taking a look at the standards that govern technical rope rescue, or technical rescue in general for that matter. So what we have is the NFPA 1006, and the NFPA 1006 tells me, or you, the responder, exactly what it is, the skills that you're required to have, the skills, the things that you'll be able to do, and the knowledge base that you should have. The NFPA 1670, well, that holds the chief accountable. That tells the chief what he has to do if he wants you to respond to a technical rescue incident. The NFPA 1983, that governs the equipment that we can use, and the NFPA 1858, that's a new standard, and that tells us how we take care and maintain and inspect that equipment. Then, of course, we have our Canadian standards, Section 21, 6-4 specifically being the Canadian standard for technical rope rescue. For the most part, that standard simply directs us to the NFPA 1006 and 1670 and says, for more information, look here. Okay, let's take a look at our two basic forms for technical rope rescue. We recognize we have awareness, operations, and technician level response. But in addition to that, we also have low angle response and high angle response. Low angle is defined primarily as any situation in which we require ropes, but the majority of our weight is on our feet, on the ground upon which we're standing. A high angle, on the other hand, would be anything, generally speaking, above 45 degrees, where the ground that we're standing on is supporting less than half our weight. Most of our weight is being supported by ropes and or auxiliary equipment and the harness that we're wearing. Obviously, the major concern, problem number one within the technical rope rescue environment is don't fall. Once we can mitigate that problem, remove that problem, reduce it as a concern, then that's most of the battle won. Just as important, however, as not falling is don't allow anything to fall on you. Helmets. Simplest solution. When we're working around or below a high angle rescue situation, we have to recognize there's the potential for things to fall on us, and we mitigate that hazard by making sure that at all times, not just while we're on rope, but any time we're working within the hot zone or even the warm zone, we have our helmets on and other necessary designated personal protective equipment. Okay, additional PPE we could be looking at, as we said, harnesses. We know we have our helmet. We need the right gloves for the job. That generally means rope rescue gloves. Generally doesn't mean firefighting gloves. Firefighting gloves tend to be too bulky, reduce tactile feeling and manual dexterity. Another glove that actually works quite well is auto extrication gloves. So if you don't have dedicated rope gloves, think about extrication gloves. All right, so we're on scene. What are our duties? What are our responsibilities? Just like anything else that we respond to in the fire service, whether it's a medical or a structure fire or a technical rescue, we start with our size up. Size up starts that morning. Yep, we all know that. It starts with dispatch. We receive that initial information, and it continues en route to the call. On arrival at the emergency scene, we're going to identify the hazards. Generally, if we identify what our problems are, just like with anything else, if we identify our primary problem and our secondary problem, that's what we're seeking to do within our size up. We're going to gather information that is applicable, reference material that is applicable. We're going to ascertain points of entry, points of egress. We're going to decide the type of rescue. Is this a low angle rescue? Is this a high angle rescue? Is this an operations level response, a technician level response? How many victims are involved? The locations of the victims. We're going to ensure that witnesses are located, identified, and that we obtain witness reports. We're going to identify what resources are required to effect a safe rescue, and any other additional information required to develop the Incident Action Plan, or the IAP. Now, while high and low angle emergency situations may have some different concerns, the overall incident management system remains largely the same. Establish scene safety zones so that the markings are clearly identified and that the zones are recognized by others at the emergency scene. Communicate the zones to incident command and ensure that everybody is fully aware of where the safe zones are and where the hazard zones are. Identify if there are options to prevent the patient from coming to further harm, and of course, protect your firefighters. Okay, so let's take a closer look at our scene control for a moment. Specifically are zone control. We have to recognize that as the first in truck, your knowledge may be limited to the awareness level, and you may find yourself functioning as scene control throughout the incident. So it's pretty important that you get it off to the right foot right from the start. We want to create a zone around the incident, generally speaking of approximately 300 feet where possible. The hot zone itself should be approximately a 2 to 1, meaning if we have an elevation of 200 feet in which we are running a rescue, we want a hot zone around that elevation where possible of approximately 100 feet. If we have an elevation of 100 feet, then we need a zone, a hot zone, around that elevation of at least 50 feet. This is obviously to mitigate any fall hazard. If something is to drop, we want to reduce the chance of it hitting somebody below. We want to remove any bystanders from the zone, anybody that doesn't need to be there at all, in fact. And like we already said, we want to establish our parameters. We want to use marking tape or barrier tape to clearly identify where bystanders can be and where non-trained personnel or non-equipped personnel can be. We want to control traffic, both pedestrian and otherwise. That actually includes non-authorized personnel from wandering into warm or hot zones, or even the cold zones, wherever we set our parameters. And of course, we want to continuously monitor and assess hazards contained inside the physical barrier. And of course, one of the things we need to think about is lockout, tagout, and blanking. I say of course, however, it is sometimes something that may be overlooked within high-angle rope rescue or low-angle rope rescue. It's something that we tend to think about for confined space rescues and elevator rescues, but may not think about for the high-angle environment. However, when it comes to wind turbines, cell towers, cranes, hydro towers, these all have the potential for energy sources, be they powered electrically, or whether they have motors, or they simply have the ability to move. Lockout, tagout, and blanking should still be a high priority. So who should be in what zone? Well, for the hot zone, that's fairly straightforward. We're looking at rescuers 1 and 2, obviously. Possibly the edgemen if they're being utilized for this evolution or this emergency. The rescue sector officer, or the RSO, almost certainly will be in the hot zone. Potentially even the ISO, the incident safety officer. Regardless of who's there, it's important to recognize that anybody within the hot zone should be in full PPE required by the incident. For our warm zone, we're looking at the hull teams, we're looking at our rigging teams, anybody operating belay systems, any other kind of support personnel. Maybe this is where the ISO will find themselves. Cold zone is generally reserved for the incident commander or the IC, as well as further back support personnel such as rehab, lighting. Generally non-technical personnel will find themselves restricted to the cold zone. However, it's important to remember that at the awareness level, we are not properly trained to utilize rope rescue equipment, nor are we properly trained to utilize rope rescuing techniques. Vitally important that we are aware of our limitations. However, as the incident progresses, you may well be asked to provide support functions in other non-technical areas. For example, you may be asked to help with haul lines. In so doing, we have to manage a haul line or assist with the raising of a patient, a rescuer, a load of some kind, and we have to understand that we need to limit our pulling efforts to approximately 50 pounds per person. This is a general amount by which to exert himself without fear of causing injury or overexertion. We need to ensure that while operating a haul line or manning a haul line, we do so with a non-jerky motion, ensuring smooth, controlled motion of the patient and or the rescuer. Beyond that, we may be asked to secure a figure eight to a designated anchor point. Something like that for us in BFES isn't going to be a problem. After all, we can all tie knots, right? Okay, in summary, we're looking at isolating the incident, protecting the victim from further harm, ensuring that we perform a thorough size-up, gathering all the information that we possibly can, identification and activation of the additional resources required to mitigate the emergency, otherwise known as our call for help. We want to ensure site scene control and site management with utilizing barrier tapes and zone. We need to recognize and mitigate potential hazards beyond the full. All right, speaking of knots, I'd say it's time to tie a few. Let's tie some knots, bends, and hitches appropriate to the high-angle rescue environment.